Look up at the night sky. Every star, every galaxy, every nebula we can see belongs to our cosmic neighborhood. This is our observable universe. It stretches out in all directions, a sphere with a diameter of 93 billion light-years. That's an unfathomably vast expanse containing trillions of stars and countless mysteries. Yet it represents only a tiny fraction of what may exist beyond. What we see is limited by the speed of light and the age of the universe. Light from distant objects takes time to reach us. The farther away an object is, the longer it takes for its light to arrive. Since the Big Bang, the universe has been expanding. This means that the most distant objects we can see are those whose light has had enough time to reach us since the universe began around 13.8 billion years ago, but the universe is much older than 13.8 billion years, and it has been expanding rapidly this whole time. So the objects whose light took 13.8 billion years to reach us have continued to move away from us. They are now much farther away. The edge of the observable universe isn't the edge of the universe itself. It's simply the limit of what we can currently observe. But what lies beyond that horizon? What secrets does the universe hold, hidden from our view? These are questions that have captivated astronomers, physicists, and philosophers for centuries. To comprehend the vastness beyond our cosmic neighborhood, we must first understand how the universe is expanding. Imagine a balloon with dots scattered on its surface. Each dot represents a galaxy. As you inflate the balloon, the dots move farther apart, just like galaxies in our expanding universe. The expansion of the universe isn't like the explosion of a bomb, where fragments are propelled outward into pre-existing space. Instead, it's the fabric of space itself that is stretching, carrying galaxies along for the ride. This expansion has profound implications for what we can observe. As the universe expands, the light traveling through it gets stretched as well. This is called redshift. Think of it like the sound of a siren becoming lower pitched as an ambulance moves away from you. Similarly, light from distant galaxies gets stretched, making it appear redder. The farther away a galaxy is, the faster it's moving away from us, and the more redshifted its light becomes. This redshifting of light is a crucial tool for astronomers. It allows them to measure distances to faraway galaxies and study the expansion history of the universe. However, it also means that there's a limit to how far back in time we can see. At a certain distance, the expansion of the universe would have redshifted light so much that it becomes invisible to us. This is the edge of our observable universe. The unobservable universe. It's a realm that sparks our imagination, a place where known physics might break down and new laws of nature could reign supreme. It's a vast expanse that we can't see, but its existence is hinted at by what we know about the universe's past and the nature of physics. One possibility is that the unobservable universe is simply more of the same. It might contain more galaxies, stars, and planets, stretching out infinitely in all directions. If this is the case, then the universe is truly boundless, a mind-boggling concept that challenges our perception of scale and our place in the cosmos. Another possibility is that the unobservable universe is radically different from what we can see. It could harbor exotic forms of matter and energy, governed by laws of physics that we can only dream of. It's even possible that our universe is just one of many, a bubble in a vast multiverse where the laws of physics vary from one universe to the next. The unobservable universe is a realm of endless possibilities, a cosmic blank canvas where our imagination can run wild. While we may never be able to directly observe it, we can use our understanding of physics and cosmology to speculate about its nature. Section 4. The Allure of Infinity. The concept of an infinite universe is both alluring and perplexing. Imagine a universe without boundaries, where you could travel in any direction forever and never reach an end. It's a mind-bending idea that challenges our intuition and our understanding of space and time. If the universe is infinite, then it must contain an infinite amount of matter and energy. This has some fascinating implications. For example, it means that every possible event, no matter how improbable, must occur somewhere in the universe. There could be an infinite number of copies of you out there, living out every possible variation of your life. The idea of an infinite universe also raises questions about the nature of infinity itself. Is infinity a real thing, or is it just a mathematical concept? Can something truly be boundless, or are there always limits, even if they are beyond our comprehension? The allure of infinity lies in its mystery and its ability to push the boundaries of our imagination. It's a concept that has captivated thinkers for centuries and will likely continue to do so as we delve deeper into the mysteries of the cosmos. Section 5. A multitude of universes. The multiverse theory takes the concept of infinity a step further by proposing that our universe is just one of many. Imagine an endless sea of bubbles, each bubble representing a separate universe with its own unique laws of physics, fundamental constants, and perhaps even different dimensions. The idea of a multiverse arises from several different areas of physics, including cosmology, string theory, and quantum mechanics. Each of these theories suggests that our universe may not be alone. For example, the inflationary theory of cosmology, which explains the rapid expansion of the early universe, predicts that our universe is just one of many bubble universes that formed from a primordial vacuum. String theory, which attempts to unify all the forces of nature, suggests that our universe is a three-dimensional membrane or brain floating in a higher dimensional space. Other brains could exist in this higher dimensional space, representing other universes with their own unique properties. The multiverse theory is still highly speculative, but it offers a tantalizing explanation for some of the most fundamental questions about our universe. If true, it would mean that our universe is just a tiny speck in a vast and complex cosmic tapestry. Section 6. Bubbles in the cosmic sea. Imagine a pot of boiling water. As the water heats up, bubbles form and rise to the surface. Now imagine that each bubble is a universe, expanding outward into a higher dimensional space. This is the essence of the bubble universe theory. This theory is closely tied to the concept of cosmic inflation, which posits that the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. During this period, space expanded faster than the speed of light, smoothing out any initial irregularities and creating the uniform flat universe we observe today. According to the bubble universe theory, inflation didn't end everywhere at the same time. In some regions, it continued for longer, creating vast, expanding bubbles of space. Our universe could be just one of these bubbles, while countless others exist beyond our cosmic horizon. The bubble universe theory provides a compelling explanation for the uniformity of our universe and the observed values of fundamental constants. If our universe is just one of many, it's not surprising that we find ourselves in a universe that's hospitable to life. After all, we wouldn't be here to observe it otherwise. Section 7. At the edge of existence, the edge of the universe. It's a concept that sparks our imagination and fills us with wonder. What lies beyond the realm of what we can see? Is there a boundary, a wall, marking the end of space and time? The truth is, we don't know. The universe might be infinite, stretching out forever in all directions, or it could be finite but unbounded, like the surface of a sphere, where you could travel endlessly without ever reaching an edge. If the universe does have an edge, what would it be like? Would it be a region of intense energy where the fabric of space-time unravels? Or would it be something else entirely, something beyond our current understanding of physics? The edge of the universe is the ultimate frontier, a place where the known universe meets the unknown. It's a place that challenges our imagination and inspires us to explore the cosmos with a sense of awe and wonder.